topic today then, combining DevOps with PKI compliance a little bit. I mean, HashiCorp, of course, is awesome at compliance for the applications and everything, and working together with that solution is very interesting. Yeah, I agree. I've been listening into many of the talks here this morning for me, and it has been a wonderful time. So, kind of the vision for today actually is that I'm not here to tell you about need for certificates or PKI per se. There's been lots of talk about that before. I actually listened to some of them from last year's Hashi talks that were really good. So I'm here because we know that the reality for many security engineers or compliance people today is like the picture on the left here, with lots of knobs to turn, lots of switches, full racks of stuff, and not a very comfortable situation overall. And we, of course, want to transition to the guy to be the guy on the right, which can lean back with a smile on your face and let the system do what it's supposed to do while you sleep well at night. So this is the vision, and this is something that HashiCorp also is very good at doing with products like Vault and Consul. What we will do here, or what I will try to do here, is zoom down on the PKI specifics, as PKI is an area which is in many cases specifically or particularly prone to compliance requirements. So my name is Thomas. I'm the CTO of PrimeKey, and I've been working with PKI almost too long now. Started in academia and been a developer and consultant and kind of all hands PKI expert all around the world. In 2001, I founded the EJBCA open source PKI, which is of course what we integrate with HashiCorp here. Doesn't have to go more into myself. And I have a little bit of background, so I know this is nothing new to most of you here probably, so bear with me just for a little while. But the supply chain that we want to secure with PKI, of course, comes from my position. And it's a supply chain that is similar in many areas, be it IoT or other ways. But in DevOps, you want to go from development, building, integration to deployment and operations, and the whole cycle has to be as secure as possible, you can say. Both as, of course, moving between different stages, but also operating within each stage. And keeping these iterations indefinitely, cycle through cycle, maintaining security over time, that's where automation comes in, and where automation is needed in order to keep it secure over time. One just interesting story is that we have one large customer who, they have been running for a long time, and they started out when they were getting certificates for their servers, they had to fill out paper forms, fax it somewhere, or email, get approvals, and then they could manually apply for a certificate, get certificate, install it on the server, etc. I mean, many of you recognize this. So, of course, that worked fine when you have dozens of servers, but today they have hundreds, so it doesn't work anymore. So, automation, and of course, things keep changing a lot as well. And another way to look at the workflow is, from one cycle to left, from left to right here, which is we have already seen today in some of the presentations I've been looking at already. Pushing code into a code repository, and apart from the repository being secure itself, we have to decouple code from security credentials. So that's even one of OWASP top 10 at some time, that credentials are kept in code. And this is, of course, where HashiCorp have some great products, which I'm sure you are all aware of. Anyhow, with the code done, CI/CD pulls down the code and runs the tests, all tests, including security tests. After passing the test, the resulting artifact is preferably, if possible, you want to code sign it, so that when it moves into deployment, you can verify that the code that you actually deploy is what has been ideally you would be able to track it all the way from code into what you deploy. And then moving into the operations, of course, there is while the code is running, the services needs to authenticate and secure communication, something which is not made in theory easier by ephemeral type of microservices, but with tools such as Consul, etc., it's made possible. And we want to do this all while maintaining high security control, and in many organizations, which we will come to right now, compliance to internal policies and sometimes external audit requirements comes in. And that's where we come into PKI compliance. A bit more details to follow. But some of the key drivers for PKI compliance or PKI consolidation in order to achieve compliance is that you have compliance or regulatory issues that you need to fulfill in a better way. So this, as I mentioned, can be both internal policy requirement or external, like PCI DSS, or if you work in government, or GDPR, etc., or both internal and external. Another cause is that you have need for consolidation due to ease operations and administration, or because the environment that you're running has become too costly and hard to maintain. So we see that a lot. And the technology is advancing quite fast and new functionality is needed. So things are happening a lot more now than it did 5, 10, or 15 years ago. From PKI perspective, this can, for example, be protocols, certificate types, or new cryptographic algorithms. There's a bunch of those coming up in the future. And business models also, of course, give rise to new possibilities, but also new demands. When organizations change, you may add business units, etc., which in turn then put additional requirements on a PKI, such as new compliance or regulations. And finally, PKI are usually very long-lived systems, and you have to calculate with both hardware and software end of life, and migration, etc. We'll have a lot of installations that can be running close to 20 years by now. So stepping into PKI consolidation, the main technical reason organizations come to us looking at PKI consolidation is because the PKI has grown over time with new use cases, perhaps new business units needing certificates, things like that. Also, different teams in the organization have set up their own PKIs, perhaps before there was a central PKI, because the central PKI couldn't fulfill their needs, couldn't operate fast enough. You need things to happen rather quickly, not in 6 months, as we heard from the previous presentation as well. Or perhaps they didn't even know about the central PKI. In any case, the result is that you have many servers and a large infrastructure to support unnecessarily large and complex. For such a key security piece as the PKI is, you want it to be as simple and secure as possible, of course. And all this makes it difficult to maintain and show compliance, which then can lead to security risks. But it also can, of course, lead to a lack of visibility and control, which can lead to certificate risks, where you don't know where and how certificates are used in the organization, expiration, and things like that. So getting into an example of this is on the left, an organization which have multiple PKIs for internal purposes. They may have one PKI for staff, issuing tokens, email certificates, and more. And then there's another PKI for networking, Wi-Fi access, VPN. And you have another one for DevOps or service mesh, one for IoT devices, etc. There's unlimited uses for PKI today. And then you also have external facing services, perhaps a web shop or booking system or something like that, which needs certificates from externally trusted public CAs. And in setup like this, each PKI has its own database. Some use hardware security modules, some don't. So there are multiple databases, keys, and HSMs to maintain control of, which can be cumbersome, at least from a compliance perspective. So then when you move to the right in the picture, consolidating the PKI, you move all those PKI databases into a single highly available system with all the keys protected with hardware security modules, also highly available, of course. And you can also consolidate the usage of external CAs, even using something like CLM tools, getting a single interface to multiple public CAs as well as internal CAs. And of course, there are, with multiple applications, there are some use standard protocols directly to the CA, while some are better served by some CLM tools, and a lot can use, for example, Vault as a single interface, as we will come to next. So we also have an example of this. It's a large customer who had something like more than 25 CAs, each on its own server. And they were also running into capacity problems with that platform because they issued millions of certificates. So after migrating everything into a consolidated system, they can now grow to millions or hundreds of millions of certificates. And when parts of the organizations needs a new certification authority set up, that can easily be done through, either manual means, of course, some clicks in the GUI, or through automation, Ansible or Terraform or whatever you like. So it can be easily handled in a reproducible and compliant way. Zooming down slightly more, even more here, if you go to talk about PKI for microservices, or we separated it into three parts, like there's PKI for microservices, which is about, of course, which is what we're focusing on today, which is about deploying certificates for workloads and applications that needs those. And the other way leg we have here is PKI as microservice, because even a PKI, how compliant you may want it, and or central, etc., you want to probably run it in as an environment that you're used to, which may be the same environment as where you run your applications, be it as containers, on premise, in the cloud, but efficiently and reproducible deployments, etc. And finally, integrity protection of code, also, or AKA code signing. I kind of put it as a blanket on top of everything, where ideally you can ensure that only verified, authorized code can be run on your system. Well, moving closer to the demo. So there's a lot to be said, as mentioned, about PKI for microservices. So I grayed out a lot of topics here, which we're not covering here today, such as like using Cert Manager plugin to Kubernetes to give TLS certificates to ingresses, or using Acme and Certbot for web TLS certificates, or deploying PKI credentials with applications with Ansible modules or Terraform and things like that. So what we will show is how to use a CA secrets plugin to HashiCorp Vault to get the secrets management with Vault to also give you your certificates from a centrally managed PKI. And also just a slide on how you can chain it then to also connect other products like Consul for a service mesh. So on to Vault. I assume here, I think it's fair to assume that you all know how you can use Vault to control very large, wider range of secrets in a consistent way with policy enforcement and everything, be it database passwords, account logins, symmetric encryption keys, you name it. There's everything you can do with Vault, kind of. In Vault, a lot of things are done using secrets plugins, and it's the same when you want to connect to any certification authority. It doesn't have to be EJBCA, as in this example. There are secrets plugins for other CAs as well, and they work just the same way. So anyhow, how it works is that you use vaults for your secret and PKI, and you have your organization have a compliant or policy-driven PKI operated by some. In many cases, there are even a separate PKI team in the organization who runs that. But you want to have your single front end through Vault for all your secrets, and then you can combine those to have both everything you want from Vault connected with Terraform and things like that with a compliant PKI. So that makes me jump into the demo. So here I have a local multi-tenant CA. So I have lots of CAs in my deployment. I don't know what it is, 30 maybe, which is what I want to issue certificates from. And I have my terminal, of course, where I will run Vault here in this terminal window. I start Vault. In this terminal, I will install the plugin and use the plugin. So this will be my client. And in this terminal, I have my PKI audit log, so I can will see that the certificates are issued and audit logged, etc. in the central PKI. So I will first start to install the plugin. So in Vault, you need a SHA-256 SAM to install plugins to have it for integrity, so you know that you actually install the plugin that you intend. Then you register the plugin. And finally, you can enable the plugin. So here I enable the EJBCA Vault plugin and with the path EJBCA v1. And you can see that Vault picked it up and deployed the plugin. Then we go on to the configuration phase. So how here I will configure a profile in Vault, in the Vault plugin. So this profile will connect to my EJBCA server with a REST API. So the URL goes there. It uses a private key and a certificate for mutual authentication TLS for authenticating Vault to the PKI. And for this profile, it uses a specific set of profiles in the CA and issued from a specific certification authority in there. So you can create multiple of these profiles to issue different types of certificate from different CAs. Maybe you have one CA for the mTLS certificates, you have another for web TLS certificates, etc. So you can just use different profiles. So I create a profile, and then I'm actually ready to enroll. So the only prerequisite I needed here from my CA is that I needed, of course, the TLS credentials from the CA to be able to create a mutual authenticated TLS connection. So here I will enroll with a certificate signing request, the CSR, to get my certificate. That's fine. We store it, of course, in Vault, so you can list the certificates that are stored in Vault. Now I will move over to the PKI audit log. So this is the CA. Here we can see that there was a certificate request came in. The certificate was stored in the CA database, and an audit entry recorded that the certificate was created. So now the certificate is centrally managed, and audit control can be shown in a compliance audit, for example. Also in the Vault, in Vault, we can see the REST API calls that were made from Vault to the CA and the response that was received. So I can issue another certificate, and then I have two certificates issued. And I can, of course, also revoke certificates using the Vault API. So if I revoke one that I just issued here, so it's revoked, and when I list it, we of course remove it from the Vault database. So now you can connect, of course, a new Vault to the CA, and then the Vault will not know about all the certificates issued, but everything is still kept in EJBCA, or I mean in the central PKI. So for example, if I could try to revoke a certificate that I issued previously when I was testing the demo, and then it will say that certificate was already revoked because I already tried it, so it's not possible to revoke again. So that was the simple demo. So of course, for those everyone who has used the normal built-in Vault PKI, it's it's pretty much the same, and it's supposed to be the same because you want to have it as plug and play as you want. So on this slide, I put a URL in the bottom, so it leads to some documentation for this and a link to GitHub where the Vault plugin is there, and together also with some, actually show it. So here's the GitHub with the Vault plugin. There's also some Ansible scripts for, we have an Ansible playbook for deploying the Vault plugin, or actually also an Ansible playbook for using the built-in Vault PKI as a sub-CA to a central root CA, which is another option that an organization may choose to do things. So there are multiple, as always, there are multiple things to do the same thing. So when we look at service mesh, so there was some great talks previously today about service mesh and console, so I really enjoy those. But if you use a service mesh in console, for example, to connect sidecar proxies with your services to enable, mTLS communication between all services and the policy-driven communication on console, then console can easily be configured to use Vault as the PKI, and of course chaining what we did before. You can chain it so console manage the service mesh, gets the certificate from Vault, which in turn gets the certificates from the center managed PKI. So you can combine things to have it both high velocity, any methods that you like and are used to, and secure and even satisfy your central compliance team if you have one. The last thing I want to mention is another thing we've been doing together with HashiCorp. So we have a product called Secure Execution Environment, or SEE for short, which is basically a full rack-mounted server that is completely FIPS 140-2 level 3 certified. And I'm sure many of you have probably heard about FIPS, and being FIPS compliant is a common requirement within cryptography, and especially if you're in government settings, it's going to be everywhere. But anyhow, what it means is that everything that runs inside the SEE, which are VMs actually, is subject to secure boot. The VMs are verified with digital signatures before started, and the whole server environment, both physically and logically, is tamper-proof when running. So combining this with Vault gives you an easy pass, or at least an easier pass to some regulatory compliance when the whole deployment runs inside a FIPS 140-2 level 3 boundary. And it's quite interesting because when you read that, reading the Vault threat model, so Vault itself, of course, is one of the tools that you will use to get compliance for your applications. But there are some threats which are outside the threat model of Vault, which then combined with the SEE, it actually closes the gap and completes a lot of the threat modeling that has been done. So the short summary: PKI compliance is important, at least for us. Applications need to be provided with PKI credentials in a very scalable and compliant way, automated. And everything can work nicely with DevOps and microservices and your fast-paced deployments. And this is one piece of the puzzle for Zero Trust. So I'm going to leave you with my cat to make you feel nice exiting this presentation. Of course, I'm happy to answer any of your questions, and yeah, you have my email. You can connect with me too on LinkedIn, and you can check out everything that we have on GitHub, etc., where we have put all this which I have shown today. Thanks for your patience.
No, Thomas, thank you. It's a really important issue, and I think it's something that we sometimes take lightly. I mean, obviously, you can use tools like Vault, and Vault's going to be incredibly good at sort of dealing with the sort of the encryption side of things. But I really like the fact that you're kind of looking more into the compliance side, ensuring that the setup that you're using actually sort of adheres to. I mean, FIPS is a big deal.